you have small, the high complexity does not mean it takes a long time. Okay. However, when you have the n number of, it will be exponentially increased. Even it has the more, depending on number of resources. So it's a very high complexity. So operating system cannot guarantee, okay, to provide a certain level of service. So it's not a good idea to use. So think about the detection algorithm. How often do you learn such a detection algorithm? Every second, every millisecond, every minute, every hour. So because of the reasons, operating system does not take care of such a deadlock problem. Instead, the application program solves such a problem. So some of the operating system adapt the combination of the such approach, but most of them do not take care of such a problem. Then why we need to consider such a deadlock management? In your application program, when you manage such a process or the program, you need to think about. Okay.
But if ultimately we kill any process, that helps for for good performance or something, because
the deadlock situation is not the problem of the performance, but it's a hang, it's a stop. You cannot use even though you have the very fast, the very high-end computer resource, whatever, because you cannot proceed the next step. It's not a problem of the performance. You need to solve that problem in case you have, because it's a stop. Okay, so at least you need to kill the process. That is the reason you stop your application program when you encounter such a problem. Sometimes it's a deadlock in the memory. So for example, when you are using the Windows 90 something, 95 or 98, from time to time you encounter something memory problem, memory leak, or the pop-up. That is actually the deadlock situation in the memory. Memory. So to allocate the memory resource, so you can use the mutex lock, okay, that you have seen in the synchronization problem. If they wait each other for the resource of the memory, same address of the memory, then they may cause the deadlock situation. Then operating system pop up such a thing. That doesn't mean the operating system kill your process, but it asks the user stop the program. Okay, so that is the currently the approach to handle such a deadlock situation. Okay, so it's done in the deadlock. So far we have discussed about the memory, the process management. As I said at the beginning of the class of this course, we have the three major parts of the operating system. One is the process management. So in the process management, we have talked about the how to create the process. What is the actually the process itself? It's a data structure. Then the thread. Thread is kind of the process. So we can consider even process as the one thread of the instruction. What if we can make the multiple thread? So that is the idea. Then we can share some common information instead of the creating entire process. Creating process means you need to use the computer resource, including the memory. So instead of the creating entire process, we are going to share some of the information. Then allocate the independent area for the process that is called the thread. We can get the higher performance. Then we have the synchronization problem in case we need to access the common, the shared data. So to address such a synchronization problem, we can use the operating system approach, software approach, and hardware approach. All of them are based on locking. Okay. Also, this week we have talked about the deadlock situation. Deadlock should be managed by the operating system. Not always. For modern operating system, actually use the application side to handle, because need a lot of the computation. So think about this resource allocation graph is anyway graph theory. Graph theory is, as we have discussed last time, is the NP-hard problem. NP-hard problem is non-polynomial. It's not optimized, which means when you have the more n, higher n, it will be exponentially increased. Okay, computation. Then, after we complete the process management, next part is the memory management. So in the memory management, we will see it's the same problem. In computer research, in the operating system, actually operating system algorithms are fighting with the limited resource. If you have the unlimited resource, you don't have to worry about too much such a deadlock situation. Deadlock situation may not be happen under unlimited resource. So memory is the same. Especially memory is a very fast, it's a cache concept. However, it's also expensive, limited access by the CPU. So we will see how to manage such a memory resource. Then followed by the file system management. So eventually the data will be stored at the file system, and file system also specific data structure to keep the very large data in between, not between, is behind the memory. So that is the overall thing. Then in your first project you will implement the I forgot the scheduling algorithm. So since we have the very limited processor resource, the processes are competing with other to get CPU resource. Who is managing such a allocation? The CPU scheduler will be in charge of such a allocation. So at the time, we can consider different algorithm. In your first project, you will implement multi-level feedback queue. Okay, so I believe that you guys can successfully implement it. Also, that will be part of your midterm exam. Okay, any question before we have the midterm exam? Any question from chapters 1 through 6? That means you are ready for midterm exam. Okay, good luck for your midterm exam. It's totally up to you how to study, but the best way of studying any subject in computer science is a textbook. I believe that is the best way. Okay, even though it covered almost 300 pages, it worthwhile for your future also. Okay, so why don't you, if you don't know how to start to prepare the midterm exam, reading a textbook, that is the best way, I believe. Okay, so if you do not have any question, so also one more last announcement. Today we have the Engineering 400, the colloquium series. We are going to invite the Professor Emil Salavis, who is in the Louisiana State University. He is majoring in the image processing, specifically the dermatology image processing, like the skin cancer. So if you are interested, you can attend, even though you are not registering for Engineering 400. Okay, thank you, and see you on Thursday during the midterm exam.